Hello. So I'm going to uh, go over this little demo I put together for the autoencoder, the basic autoencoder. This is a very simple example where what I'm doing is I'm creating a very simple autoencoder neural network, which consists of a encoder-decoder architecture, which has one hidden layer. We're going to use the TensorFlow libraries here, and we use the sequential library for the actual neural network architecture. We add the dense layers, which are just going to be a dense neural network. And we import the fashion MNIST dataset, which is a simple toy dataset that comes with Keras that has compressed images of clothing, shoes, hats, shirts, etc. So we're going to use NumPy and TensorFlow to do the actual work of the neural network and train it and do predictions on it and then visualize the output. So the training, we split the data set into the training and test data. So that's this load data here because we want to actually train the neural network, and the test data is going to be typically used for validation on our outputs. So we're going to actually do the prediction on the test data. So we simply define a simple neural network using sequential through this model. We add our, this is now our hidden layer here, and this is going to be, we're going to use a 256 node neural network hidden layer with ReLU activation. So that's rectified linear unit. It's a very common activation function used for neural networks, and it avoids things like exploding in gradient or hidden gradient. And then we're going to use the actual output layer, which is going to be a single 784, which is 28 by 28 pixels of images, because the output is going to be in a single line. Now, we're doing this here because we are reshaping the data, the training and test data, because we want to actually input it into the neural network, and so that each node is lined up. And so this is the number of nodes for the input, 28 by 28, because that's the size of the data. We could use a convolutional neural network to do this, so you can take image data more naturally than doing it layer by layer, but this is just for the simple autoencoder example. And we, again, normalize this data so we can essentially make this training for us more easier, and we don't have to worry about magnitude of inputs. And so we have now, after we've defined our model, we compile the model. It's the first step. So we'll use the basic atom optimizer, which has a loss function, mean square error. We can use a different loss function as well, but again, this is a pretty simple neural network architecture, so most simple neural networks use mean square error. And then we actually do the training. So we use the .fit function from TensorFlow from our model, and we take our input training data, and we then do the output. So we take 10, we're going to use 10 epochs of training, and we're going to use a batch size of 128. So we do our predictions on our test data, and we take our index to visualize, which is going to be, we're going to take just simply, when we do our output to demonstrate how the autoencoder looks, we're going to just take the first instance of an image. We could take any instance of an image as well in the fashion MNIST data set and output that. So we're going to run this. And so I have this Colab environment, which is this high RAM environment, which is very useful, and using probably their fastest TPU currently available, which is like their TPU2. So the training looks like it progresses actually pretty fast. And so once we get to the final output, I've run this before also, but still, it's, you know, we're training from scratch here. And finally, there you go. There's the input, and then there's the output. Looks very close, right? The input and output are, this is essentially what a reconstruction is from the autoencoder. So you're not going to see much difference if you take another example. If you take index 6 and do the same thing, you'll see another piece of clothing. Now, the one thing with the autoencoder, it's used to build more advanced models. That little variation is essentially what generative AI takes advantage of, using the generative autoencoder or the variational autoencoder, and creates a whole new object. So that's another type of simple generative AI. And we'll just wait until the next iteration is complete. And again, so that was some hoodie, and that was compressed, and then you can see there's a difference in the output hoodie, but it looks like mostly the same hoodie. And we can do things like take the difference in error and whatnot of that. So that's a simple autoencoder example. Thank you.